So the question they have given at us, check whether the signal is periodic and find its fundamental period. So let me take the first question, cos of pi n. Okay. So this is nothing but omega of n. Okay. So this omega value is nothing but pi here. Okay. So what is a form of a fundamental period is n, capital N. That is your fundamental period. Okay. Fundamental period. That is equal to 2 pi by omega naught. This is omega naught into m. Okay. So you substitute here into m. So you will get 2m. So whatever the value of m, okay, so the m will always take some value, right? So if m is taking some value, for example, if it is 1, this is integer, this becomes 2, right? If m is equal to 4, 5 and 6, whatever the value, this becomes so integer value only. So it is the signal is periodic, okay, and the fundamental period value capital N is equal to 2. Okay. So let us go to the next problem. So the next problem they are given it as 12 cos of 20n. Okay. So this is your second problem. So here I can write n is equal to 2 pi by omega naught. Omega naught value is 20, right? This is my omega naught value. Okay. So m, so I will get pi divided by 10 m. This is equal to 0.1 of pi m. Okay. So whenever the pi comes, means it becomes a irrational one. Okay. So therefore this is nothing but a aperiodic symbol. Okay. Since it is a aperiodic signal, the fundamental period, though the fundamental period is this one. So if I substitute m is equal to 1, you will get 0.1 of pi. What is 0.1 of pi? 0.1 of pi is, this is nothing but 0.1 into 3.144 something. Okay. So you will get the answer like, so it will, it is a continuous one. It is not stopping. It is infinite one. Okay. So that is why it is called as a aperiodic signal. Okay. So next, third problem is e power j 2 pi by 3 n plus e power j 2 pi 3 pi by 4 of n. Okay. So here this is nothing but your omega naught value. This is also another omega naught value. So first let us take for this one. So there is nothing but 2 pi by 3 omega naught. So m. Okay. So this becomes 3m, right? So similarly for n2, it is 2 pi divided by 3 pi by 4. So this becomes 8 divided by 3 of n. Okay. So the n1 value is this one and n2 value is this one. So if I divide n1 by n2, I will get 3 divided by 8 by 3. So that is equal to 9 by 8. So here if I want to make so here if I want to make this one as integer, if I substitute m is equal to 1, if I substitute m is equal to 1, this becomes 3. If If I substitute m is equal to 3, this becomes 8. So now I can write n1 by n2 is equal to 3 divided by 8. So the overall n now n is equal to 8n1, that is equal to 3n2. Okay. So if I want to make this one, so you substitute 8 into 3. This becomes 3 and this becomes 8. So you will get answer as 24. The LCM of this sum, 3 and 8. So, okay. So the LCM of 3 and 8 is your answer. That is 24. Okay. So fourth problem, x of n is equal to e power j 7 pi divided by 3 into n. So here n is equal to 2 pi divided by omega naught. Omega naught value is 7 pi by 3 into m. So this two get cancelled out. So you will get 6 divided by 7 m. For m is equal to 7, n is equal to 6. So it is a periodic signal, right? It is a periodic signal. And the fundamental period value is 6. Okay. Now let me go for fifth problem. X of n is equal to sine 2 pi n plus sine 6 pi n. Okay. So here the n1 is 2 pi divided by 2 pi m. n2 is 2 pi divided by 6 pi m. Right? So this is equal to m. This is equal to 1 divided by 3m. Okay. So for m is equal to 1, this is 1. For m is equal to 3, this is 1. Right? So the answer is 1. Okay. So my n1 divided by n2 is equal to 1 by 1. So n is equal to n1, n2, that is equal to 1. So the fundamental period value is 1. Now let us go for the continuous time signal. So if the continuous time signal means, the question will be like this. Instead of x of n, it has to be x of t. X of t is equal to 50 pi of t. So here you have to find the fundamental period, right? So the fundamental period here is, instead of n, you have to use capital T. So the formula is 2 pi divided by omega naught. Okay. So you should not have m here. So it is nothing but 2 pi divided by 50 pi, that is equal to 1 divided by 25. So t value is 1 divided by 25 seconds. So it is a periodic signal. So next let us go for the second problem. Okay. So x of t is equal to j e power j 5t. Okay. So here what is the formula? T is equal to 2 pi divided by 5 naught. So here 2 pi divided by 5. Okay. So it is a irrational number. So it is an aperiodic sign. And now the pi comes, it is aperiodic sign. So for this one, this is a time period, fundamental period, but it is a aperiodic sign. Okay. So next, let me take the third problem. X of t is equal to 2 cos 10t plus 1 minus sin 4t minus 1. So here my t1 is 2 pi divided by, this is my omega naught, that is 10, that is pi divided by 5. Again for t2 it is 2 pi divided by 4. So it is nothing but pi by 2. So if I want to find the value of t1 divided by t2, that is equal to pi by 5 by pi by 2. That is equal to 2 divided by 5. Okay. So this I can write it as, okay. You have to take the LCM of the numerator. LCM of the t1, t2, right? Divide by HCM of the denominator. Okay. This is the LCM of the numerator. Okay. The LCM of the numerator is pi and pi, right? And this is pi, this is also pi. So the LCM is also pi. So in order to find the fundamental period. And the HCF of 2 and 5 is nothing but 1. So the answer is pi second. Okay. So let us now come to another problem. X of t is equal to cos 60 pi t plus sin 50 pi t. So what is t1? T1 is equal to 2 pi divided by 60 pi, and t2 is equal to 2 pi divided by 50 pi. So this is t2, it is equal to 1 divided by 30 by 1 divided by 25. So what is the answer? 25 divided by 30. So it is 5 divided by 6. So it is in I can see integer. It is like this. There is no pi and how it is coming. So it is periodic. Okay. So if I want to find, so this is your numerator. So if I take the LCM of this numerator, the answer is 1. And if I take the HCF of the denominator, 30 and 25, so the answer is 30, 25. It is 5, 6, 5. So the HCF is 5. Okay. So my T is equal to LCM divided by HCF, right? So it is 1 divided by 5. Second is your answer. This is your fundamental period.